All right. This fine fellow up here is our bestie from Deno. Kevin Whinnery is head of DevRel at Deno, and he made one of my favorite things ever, Twilio Quest, which was a game that introduces you to programming concepts built on top of Electron. I love the interactive learning that this guy's gotten up to in his career, and I'm going to let him take it from here.
Very much, appreciate it. All right. Very cool. Thank you very much for the kind intro. And you know, I'm actually going to put you to work a little bit, Rachel Lee, at the beginning here, because we were asked to provide like some embarrassing facts about ourselves to Rachel Lee that they could use against us. And it was very difficult for me to choose just one, so I had to like narrow it down to a category. And to start things off, we're going to play a little game of two truths and a lie, where you will have to decide among three potentially very embarrassing injuries which ones actually happened and which one is a lie. So. To get things kicked off. So the first option is, did I trip on a curb, fall into a statue of Tyrone from the Backyardigans at Mall of America, and cut my head open and require 2 stitches? That is injury option number 1. Injury option number 2 is, did I sustain a leg injury requiring surgery at a corporate team building event that involved bubble soccer? Or number 3, did I sustain 2 concussive force injuries in the same 9-inning baseball game below the belt, like where you probably don't want to endure such injuries, and have to have that happen twice in a single day in a single game? So I would put it to you, and perhaps even you could ask our friends in the audience to see, like, which one do you think is the lie of the 3?
We're going to do this by cheering. And also, my apologies, I am rusty. Please be patient. I was supposed to help you with this, and I forgot. So, 2 truths and a lie. The way this is going to work is, as Kevin calls out each one of these scenarios, you're going to clap if it's the lie. Yes. And we're going to see if you can spot which one of these scenarios is the lie, because 2 of them actually happened. Kevin, you ready?
All right, so if you believe that number 1 is a lie, please clap your hands.
Can you restate what number 1 is?
I tripped on a curb, fell into a statue of Tyrone from the Backyardigans, and required stitches at a trip to the Mall of America.
Okay, who thinks that that is the lie?
Okay, got a few folks who think that's the lie. All right, number 2, sustained an injury requiring surgery at a corporate team building event that involved bubble soccer. Who thinks that's a lie?
Okay, I think that one's the lie.
Pretty robust. I think that's probably more than number 1. And number 3, who thinks the lie is that I sustained 2 concussive force injuries, not to the head, unfortunately, in the same baseball game where I had to come out of the game twice? Right, it's kind of even between 2 and 3.
Sounds like a tie, but I feel like the middle one is the one more people think is the lie. So.
Okay, we'll go with that one. Unfortunately, that actually happened. I had to have an Achilles tendon repair surgery after participating in bubble soccer at a Twilio team building event once.
You get in a lot of injury situations.
It was kind of like, it was even hard to come up with these 3. Like, there's definitely more. And I did play college baseball, and that happened to me twice in a single game. So that was not very much fun, and I was teased mercilessly for it, as you might imagine. The first one happened to my youngest son, actually, because I am an excellent parent, and he was under my supervision, but he fell into a Tyrone statue and required stitches. So killing it as a parent, obviously.
To be honest, those last 2 were really close, so I think we're going to give it to the audience anyway.
I think so. I think that was close.
Yeah, I think my hearing was a little off on that one.
All right, well, thank you very much. I appreciate it.
Great job, everyone. You spotted it.
All right, well played, well played. All right, so let's get into it. What's up, everybody? My name is Kevin. I'm a member of the Deno team, and today I get to talk a little bit about what's getting cooked up for Deno 2.0, which we're hoping drops later on this year. So I do want to actually take a moment first, though, to thank like all the organizers and everybody who worked on putting the show together, and also AWS for letting us use this theater, where somehow like even heartbreak feels good in a place like this. I can't put my finger on it. but an amazing venue, so thank you very much to everybody who helped out. But again, the order of operations here, we'll talk a little bit about what Deno is, like if you haven't heard of it before, kick the tires. We'll talk a little bit about what's happening in Deno 2.0. I actually have some pretty exciting stuff to share. And then we'll also just kind of close by briefly talking about why Deno is a thing, like node.js exists. Why do we care about Deno? And I think that's a fair question, and we'll talk a little bit about kind of why that is. So let's get started with kind of quickly what Deno is. So Deno is an open source JavaScript runtime. It was created by, originally created by Ryan Dahl, who created Node.js. And it's written in Rust. It uses Tokio and Hyper for asynchronous I/O in Rustland. It also embeds V8, much like the Node.js in runtime exists today. But some key sort of characteristics of Deno are that it's sort of a batteries-included JavaScript runtime. So without any additional configuration or tools to install, you can write TypeScript, JSX, and have some of those tools that are just available as a part of the runtime. There's also a built-in formatter, linter, test framework. The sort of philosophical thing you'd notice about Deno right away is it's a little more opinionated. There's a little bit more included as a part of the runtime versus sort of abdicating that to userland. The other thing you'll notice is that Deno really strives to be like the programming environment of the browser. So rather than introducing new APIs for things that do exist in the browser or as web standards, we really religiously try to use web standards to expose interfaces. So a simple example of this would be instead of having a special HTTP request and response object that's part of Deno, we actually use the same interfaces that are available in the Fetch API in the browser, even in a server environment where you're responding to HTTP requests and then returning HTTP responses. So the third is probably also something that's most notable, which is a secure runtime by default. So when you run a Deno program, you have to explicitly enable access to the file system, access to the network, and other potentially sensitive APIs. So this is another core design decision that you'll notice in Deno. In addition to the runtime, Deno also has a cloud environment for running JavaScript applications called Deno Deploy. So it's a globally distributed edge network. It runs in about 30 data centers all over the world. And it's possible you've actually used it already without knowing it. So if you've used like Netlify edge functions or Supabase edge functions, those are actually built on top of Deno Deploy. And kind of the primary thing that makes it different from a lot of other hosting or sort of cloud environments is that rather than managing virtual machines, Deno Deploy manages V8 isolates. So instead of cloning an operating system, it's a lot closer to creating like a browser tab. It's an isolated JavaScript execution environment that's running your code. And what that enables, in addition to being able to serve a lot of traffic at the edge, is very fast deploys. So when you are deploying an application, oftentimes, if you're writing Deno code that doesn't require like a lot of pre-processing, you upload your code, you merge a pull request to main, and almost instantly that code is available across the entire network. So I think it's probably more useful though to just very quickly show a Deno application that kind of illustrates a few of these things. We'll just want to take a brief look at how these pieces come together, just to give you a more visceral sense of how it works. So what we have here, I do have a little bit of code pre-written here, but I wanted to kind of call out a few operative things that are maybe different about Deno, especially versus what you might have seen in Node.js. So with Deno, you have JavaScript language features that might not be available without a flag in Node.js today. So like you'll maybe notice right away like top level await, like outside of an asynchronous function block, which is starting to filter into other JavaScript environments as well. But the other thing to point out is there are lots of APIs that we can expose that are web standard. So within this like HTTP server, which is just like a simple like link shortening service, is what this code actually does. We do have the request object that I was talking about before from the Fetch API, but everything that isn't web standard will be a part of this like Deno namespace. So serving HTTP requests, not something that exists as an API in the browser, so that's part of the Deno namespace. And another thing you'll notice is this application implements link shortening by using a key value store. So Deno KV is a key value database that's actually built into the Deno runtime. And that's actually part of a design philosophy of Deno that I'll talk a little bit about later, which is essentially providing more primitives as part of the runtime in trying to build out like a more complete web platform for the server. So again, we'll talk about that a little bit more in a bit. But yeah, like we also here have, like without any configuration, there's just a single file in this folder. So we have TypeScript support again out of the box. So we have, the types that we can inspect within Visual Studio Code. There is a Visual Studio Code plugin for Deno. I definitely suggest that you check it out if you do want to kick the tires on Deno. But again, like most of this is just kind of available as part of the runtime. So if I go out here, I'm going to run this code with Deno run -a. -a just gives it like unfettered access to all the APIs that it would want to use. So kind of defeating the purpose of the secure sandbox environment, but it is fewer characters to run. And so if I run that, I have a server going here on port 8000. And if I bring up like an HTTP client, I can post a JSON body that will, oh, actually that's pointing at a production server, not my localhost. So if I point this at my localhost, it has a similar effect where like I'm creating like a slug and a short link that forwards to deno.com. And if I do a get against that, so once again, we'll switch it over to localhost, port 8000. That's just going to do a 301 redirect to a web page that's configured in the database. So this is all well and good. It works locally. Again, like that key value database is part of the Deno runtime, so it's kind of part of my development environment without really having to do anything. But it's also part of my deployment environment potentially in Deno deploy if I want that to be the case too. So let's go back out here and I'll go out to this project console. So on Deno deploy, I'll just create like a new kind of blank project. And then what I can do is I can run deploy CTL, deploy, and then we'll push it straight to production because that's how we roll here during the demo. And I think the project was what, week cat 11? Great, and then mod.ts is the sort of entry point to my application. That mod.ts is actually kind of a convention that's arrived from Rust. Like the entry point to a Rust program is often called mod.ru or whatever. So that's kind of where that comes from. So now in a few moments we have a new application deployed, and if I go back to my HTTP client for the post, I'll just kind of drop that in there. And it's creating a new version of the link there. And then similarly, if I just like change this to a get and send, the body won't actually do anything. That's weird. So if I send a get request, oh, I do have to provide a slug. So I think it was my link is what it was called. And then that again is going to forward to my the web page that I had configured. So the kind of operative bit here is like I didn't have to like provision a database or like set up any keys or anything like that. The way that my code works in the runtime locally is also the way that my code works in my deployment environment, which again I'll kind of talk about in a little bit more depth towards the tail end of the presentation here. But heading back here, that's a little bit about kind of Deno today, how Deno works. But I also wanted to share a little bit about what's going on with Deno 2.0. So Deno's been out for a little over 5 years now, and 2.0 will be a pretty major change for the runtime itself in a couple of different ways. So up here, this is actually one of my favorite Hello World examples of Deno because it shows how like in a single file, without configuration, you can create JSX components that you can then render out in response to an HTTP request. It's one of of the more fun, sort of batteries included examples of Deno. One of the things you'll notice in this code sample, though, is a feature that is pretty unique to Deno, which throws a lot of people for a loop initially, which is these HTTPS import URLs. So instead of just importing a bare specifier of some kind, as you might if you were going to require import a node module, you can actually use an HTTP URL to specify where you want to pull in that dependency from. And when Deno was originally created, there were a couple of reasons why we did this. The first one was that it's much more browser-like. The way that you import modules, like if you use a browser that supports ECMAScript modules today, you can specify remote or like relative URLs within your imports in your JavaScript that will import modules that exist on your server. So we wanted to kind of increase the portability of code again that you could write between both environments, and again favor sort of the most web-like programming environment possible. Another nice thing is that it's decentralized, so like there can be multiple places where modules can live. So there's more choice in userland where you import those modules from. But it's also really, really efficient. So instead of downloading a whole tarball with that, which has like readmes and tests and like other stuff that you might not necessarily need in your application, you're really only downloading the files that you need for your actual software to run. So there are some like really nice things about HTTP imports. However, there are some challenges too. So one of them being disappearing imports. And this is something that we've just kind of seen in practice as more applications are coming online in Deno, where a server with your dependency goes down at an inconvenient time, like when dependencies are being cached, or the content subtly changes. So like if you're using a service that has kind of spotty uptime, you might get a slightly different version of an asset than the one that you originally requested. And there's mitigating things that you can do for these things, but it was a problem that we saw as a practical matter pretty frequently. There's also a problem of duplicate dependencies. So there's no good way to know that you have different versions of the same dependency, or you're importing the same dependency from different servers. Deno can't really do a lot to like optimize the dependencies it's pulling in based on semantic versioning. So this like sort of spread out decentralized model of managing dependencies has some practical implications there as well. There's also just some developer experience problems with this approach as well. Like configuring URLs is a little bit tedious. It's kind of nice to be able to just say, npm install express, and you just get whatever the most recent version of that module is. One thing as a module author that I missed right away in the Deno environment was the ability to do like an npm link, where you're working on a version of a module and you can kind of swap that out in another project, so you can test how your module works in the context of that other project. So there's a number of things that where HTTP imports are kind of coming up short, to the point where it became clear that HTTP imports were not going to be the future for Deno, and we knew that we needed to go in a different direction. And this is a problem that's been solved many times with a centralized package manager, where you can actually do some of the dependency resolution, enforce semantic versioning, and those types of things. And of course, notably, in the JavaScript ecosystem, NPM is doing this job today for node.js. So we had kind of a decision in front of us where we were thinking about like, all right, we decided that we kind of do need to go in this centralized package management direction. Is NPM a thing that's going to work for us? And we put in a lot of work to kind of figure out if that was going to be the case. But for a couple of reasons that I'll share here in a minute, we ultimately found that like NPM had a lot of cruft in it that we didn't necessarily need in the Deno environment. So we ultimately decided that it's going to be time for us to build a new centralized package manager that's specifically built for Deno first. And some of the features of this registry are that we do want to actually take an editorial stance on content that's in the registry. So we want to actually prevent squatting on specific names of modules and packages. And prevent like abandoned modules from like taking up a namespace like MySQL. And we think it's to the benefit of the developer community to make sure that like whatever the MySQL module points to is actually like a helpful version of that type of code. So we want to kind of reserve the right to take that editorial stance when required. We want to ensure that packages published to the registry use semantic versioning, that they're TypeScript aware, so we can actually run Deno check, which checks the types used in a module, so that if it is a TypeScript module, it's something that can be used successfully. We want to ensure that there's licensing that's configured, and we can also build the registry in such a way where we can retain a lot of the efficiency that we had in HTTPS imports. So we're hard at work on this right now. Ultimately, this is going to be hosted on denoland/r, which if you go to this URL, there is nothing there today, so don't bother checking it out just yet. But we're pretty stoked about this direction. And ultimately, like what we want to be able to do is, with Deno, again, we're not trying to copy paste node.js. Like we're trying to create a different type of developer experience, and we think that this registry is going to be a key part of the developer experience that we're trying to create. So how's it going to work? Very similarly, actually, to how you manage dependencies in a Deno project today. So you don't need a Deno.json in your project by default, but you will want one if you want to kind of manage. It'll be sort of maximally convenient to have one if you want to manage packages through the Deno registry. So we actually support npm packages in Deno today by using an npm specifier. So npm : whatever the name of the package is, and then a semantic versioning identifier for like which version of the package you want to bring in. So that model will remain, but we'll introduce a Deno specifier for packages that are explicitly built for Deno. And then to use them, it'll look very similar to how you would use the import maps today, or how you would import from a npm module that has a bearer specifier as well. In terms of other ways that the registry will work for private registries, that we imagine there being a few ways in which that can come together. The registry software itself, we're explicitly designed to be really easy to self-host. It's going to be mostly based on object storage and should have enough, like few enough moving parts to be pretty bulletproof and hopefully, survive nuclear attack was the words that I heard from Ryan most recently. And we'll also, continue to be able to support private npm registries and other software solutions that do private registries as well. For the publishing workflow, very similar to if you've published an npm module before, you'll have a deno.json, which specifies the name of your package, the version, and then we'll have command line tooling as a part of the single download for the Deno runtime that'll help you publish those modules as well. And if you do build a module for Deno, one tool you'll definitely want to check out is DNT, which actually takes a Deno module that's written in TypeScript and actually transpiles it to both a CommonJS and an ESM module for Node.js. So it's actually like really kind of nice to create code in Deno and then export that to Node.js, like with all of your tests, and be able to support both CommonJS modules and ESM from the same code base. We'll also be looking at how to do patching and workspaces more efficiently within the context of a Deno project in the same way that you would be expected to with NPM. So do want to wrap up here before too long to get us back on track. But if you want to keep tabs on what's going on with Deno 2.0, definitely feel free to join us on the Discord and sign up for the newsletter to be the first to know about Deno 2.0 news. And the thought I'll leave you with is kind of why we are doing this. So the sort of why begins, I think, with some of the technical things that Ryan wanted to address with Node.js, which he talked about initially a little over 5 years ago, I believe even introduced by our friend Rachel Lee Neighbors, where he talked about some regrets that he had about Node.js and some ways that he would have approached it differently. And but just as a point of order, he calls it Deno in the talk, but it is canonically Deno. So that gets super, super confusing. So just as a note there. But a lot of the technical goals of Deno, I think we could credibly claim are true in the runtime today. So it's very good at serving network requests. It is, the runtime is secure in such a way where it's hard to execute the same kind of supply chain attacks that are possible in Node. We also have built in enough into the developer experience where you don't have to install 15 different tools in order to get work done. But building, a new version of Node.js in a lower level language like Rust is not the point of Deno. Like just rewriting a better version of Node that is incrementally faster and better is not really a very interesting reason to undertake a project like this. The real goal of Deno is to try to radically simplify how software is built for the cloud. And the way that I like to explain this is when you're writing code for the browser, your responsibility kind of begins and ends with the code that you write. You have HTML, CSS, and JavaScript. You send it to the browser, and the browser does everything necessary to interface with the operating system to do the things that your code does. And you just have to interact with like the storage APIs, service workers, all the things that are available in the web platform to build your applications. But on the server, that's not really the case today. Like even if you're using a serverless runtime, there's lots of other services that you have to build your stack from scratch. So we want to, with Deno, bring the experience of developing for the web platform to the server as well by providing primitives like a key value store, other kinds of databases. We'll be shipping a queue abstraction here very shortly, and essentially like make good on the promise of serverless, which is saying like, all right, your responsibility as a developer begins and ends with the code that you provide. And the runtime is going to do the work of making that true for you. So making that local development experience where you can write the code and it works on your machine. And with some caveats, you put it in production and it works basically the same way. That's the promise that we're trying to make good on with Deno. So with that, if you want to try Deno, recommend using Fresh. It's the sort of next-gen web framework that's built on a kind of an island architecture, which is server-rendered by default, sends zero JavaScript to the client by default. Very much fun. I've recently gotten into it myself, and I kind of don't think I can go back to having a build step in my web application. So definitely suggest that you check it out. And if you haven't already, our host Carter Rabasa is an excellent karaoke performer. And if you haven't gotten to enjoy his musical stylings before, I definitely encourage you to stop by the after party because it is truly a sight to behold. So thank you very much. Appreciate it.